26.3 VO2 max. Dan Constantine. Introduction. What is VO2 max? According to Quinn 2019, VO2 max, also known as maximal oxygen uptake, is the measurement of the maximum amount of oxygen a person can utilize during an intense exercise. VO2 max is measured for different reasons, which are usually health or sport related. Measuring VO2 max is important for endurance athletes such as marathon runners and long-distance cyclists, but is also important for games players such as athletes like footballers and rugby players who still need a good aerobic capacity. By measuring their VO2 max, they are able to see how their lungs can work during exercise and can then use this to track progress in training. This is beneficial as they will be able to see if their training is working, as their VO2 max results should improve. Landsman 2016 states that from gaining VO2 max results, Dr. Schallenberger has designed a computer program that evaluates your ability to produce energy and can predict your future health. Therefore, VO2 max is useful for health-related reasons as well because the results can be used to see how good your body is at producing energy, which can determine how healthy you are. From measuring VO2 max, the participant is able to see whether they need to start exercising and eating better, as having poor VO2 max may suggest that you are unfit and at a higher risk of health issues. The health and sports related normative data can be seen in figures 3 and 4. Nicodemus 2015 states that absolute VO2 is simply the maximal rate of oxygen uptake you reached at the end of the test and is expressed in liters per minute. However, larger people may have higher VO2 max scores, but they also need to carry around more weight, which means they may not be able to complete the VO2 max test with as much speed and power output. Therefore, VO2 is divided by body weight in kg to express VO2 relative to your body weight, and it's expressed in milliliters over kg per minute. This is stated by Nicodemus 2015. The gold standard and direct method for measuring VO2 max is gas analysis. However, there are indirect measures such as the ones we are using in this experiment, which are the multi-stage fitness test and the Queen's College step-up test. Indirect tests can be maximal, athletes exercise until they physically can't go any longer, or submaximal, athletes work until the test is finished instead of stopping when they are too tired. Submaximal tests include the yo-yo test and the multi-stage fitness test, whereas submaximal tests includes a Strands-Brahming cycle test and the various different step tests such as Harvard, Chester, Queen's College and Forestry step tests. In figure 1, you can see a VO2 max chart. The diagonal line represents an increase in oxygen consumption as the intensity of exercise increases. The point at which the line starts to plateau is the participant's VO2 max, which means that that is the maximum amount of oxygen they can use during intense exercise. Gas analysis is the gold standard test for measuring VO2 max, which means it is a direct test. The test is done by putting a mouthpiece in the subject's mouth, which is connected to a tube that leads to a gas analyzer. The participant will then start exercising, usually on a treadmill or an exercise bike, and the gas analyzer will measure the oxygen consumption, CO2 production, and expired ventilation. In a study conducted by McFarlane et al. 2011, it was concluded that a particular portable gas analysis system produced acceptable, stable, and reliable results, but was not a valid method for during moderate and highly intense exercise unless further correction of VO2 and VCO2 was completed. The portable gas analysis was compared to the Douglas bag method, and they found that the gas analysis overestimated VO2 and VCO2 by 10 to 17% at moderate and vigorous exercise. However, the sample size was made up of 8 adolescents, which means the reliability of the test is quite low. As only 8 people were used, it could affect the conclusion of the results as there were not enough participants to show if the test provides valid results. Also, all of the subjects were adolescents, which could mean that they have similar characteristics which will affect the generalization of the results. Another study conducted by Vogler et al. 2010 shows that a type of gas analysis equipment gave significantly higher results for VO2 and VCO2 compared to the Douglas bag system. This could show that the gas analysis may not provide valid results, but it may also show that the Douglas bag system is not a reliable way of measuring VO2 max. However, a sample of 8 people was used, which may affect the reliability of the results, as there were not enough people used to know for sure if the tests were valid and reliable. Method: Pre-test procedure. Before the test, the subjects were given an informed consent and a pass key to sign and fill out. This gave the relevant information on the subject's medical history so that we knew it was safe enough for them to participate. The subjects were volunteers and were aware they had the right to withdraw at any time. The subjects were told what the purpose of the experiment was, and the protocol of the tests were explained so that they knew what to expect. A risk assessment was also created to outline any possible hazards that may occur in both tests so that controls could be put in place to stop them from happening. Then, a risk-benefit analysis was completed to determine whether the benefits of the study would outweigh the risks so that we knew it was safe enough to carry out. After the subjects had been briefed so they had full knowledge of the purpose and what the study was about, they were given participant disclaimers to verify that they knew the risks and were prepared to willingly take part in the test. An equipment check was completed before the test to make sure there was no damage or faulty equipment, and after the test the participants were debriefed so they knew what was going to happen with their results and that there would be data confidentiality involved. The multi-stage fitness test. The multi-stage fitness test is a maximal running test but is indirect as it estimates VO2 max based on what level you reach. 2 cones or lines will be set up 20 meters apart from each other, which will be the markings for where the participants will need to stop running and turn around. The participants will start on one line, and when they hear the beeping noise, they will run to the other line 20 meters away. Once they reach the other line, they must turn around and wait for the next beep. When they hear the beep, they will have to start running again back to the line they started at. The time between the beeps will shorten, making it harder for the participants to reach the line before the next beep. There are 10 beeps in each level, and as the levels get higher, the intensity at which the participants are running at will also increase. The participant will stop once they can no longer keep up with the beeps for more than 2 beeps, and their score will be recorded. Their result is then put into an online calculator, as you can see in figure 9, which takes age and gender into account and will then give an estimation of your relative VO2 max and a rating such as above average or poor in relation to the normative data. The Queen's College Step-Up Test. According to TopEndSports.com, the Queen's College Step-Up Test requires a 16.25-inch step, a stopwatch, and a metronome or cadence tape. The protocol involves using a 4-step rhythm in an up-up-down-down method on the step, and for females this will be at a rate of 22 steps per minute, whereas for males it is 24 steps per minute. The participants will have to stay in time with the beeps for 3 minutes, and as soon as the test is over, they must stop immediately. Then the participants must count their heartbeats for 15 seconds straight after they have finished the test. The amount of beats they counted is then multiplied by 4 to work out their BPM, beats per minute, which will be used in an equation to estimate their VO2 max. For men, the equation is 111.33 minus 0.42 times their BPM, but for women it's 65.81 minus 0.1847 times their heart rate in BPM. Results. After conducting two tests for the multi-stage fitness test and the Queen's College step test, we have gained VO2 max results for a participant by using an online calculator and the relevant equations for the subject's age and gender. 2 tests were completed for each test to ensure that test-retest reliability as it supports the reliability, validity, and accuracy of the results. The participant's data that is being used was from a basketball player. For the first multi-stage fitness test, the basketball player scored 10.7, which gave him a relative VO2 max score of 49, and in the second test he scored 10.8, which gave him a score of 49.3. The mean of these two scores was then calculated by adding them together and dividing them by 2, which gave us a final result of 49.15. This can be seen in figure 4. For the first Queen's College step-up test, the subject counted 32 beats in 15 seconds, which means he had a BPM of 128 after multiplying the 32 by 4, as there's 4 15s in the 60 seconds. For the second test, he counted 35 beats, which gave him a BPM of 140. After finding his BPM for both tests, we used the formula that was previously mentioned to work out his relative VO2 max score. The equations were then 111.33 minus 0.42 times 128, which gave him a score of 57.6 milliliters of oxygen per kg. And from the second test, we got 52.5 by using the same equation. Again, the mean of these two results was calculated, which gave us a final score of 55.05 milliliters of oxygen per kilogram. For the multi-stage fitness test, the participants scored 10.7 and 10.8, which is good compared to the normative values for males, as shown in figure 5. This shows that his aerobic capacity is quite good, and he was able to stay in time with the beeps until level 10, and nearly made it to level 11. In figure 2, you can see the ideal VO2 max for different sports and for different genders and ages. For a male basketball player between the age of 18 and 30, we can see that their VO2 max should be between 40 to 60 milliliters of oxygen per kg. In both tests, our subject's VO2 max results were between 40 and 60, as he scored an average of 49.15 in the multi-stage fitness test and 55.05 in the Queen's College step test. Therefore, the participant is at an ideal VO2 max level compared to the professional athletes in his sport. This is extremely beneficial as it means that the subject will have a good aerobic capacity, which will allow them to exercise or play for longer without fatigue, as his aerobic system will be able to get enough oxygen into the muscles. According to Workplace Health and Safety Queensland, high levels of fatigue can cause reduced performance and productivity and increases the risk of accidents and injuries. Therefore, if the aerobic system is providing a sufficient amount of oxygen, then fatigue will take place more slowly, which means the basketball player's performance will be better and more consistent. Also, they are at less risk of injury as their technique will be better due to more energy, allowing their movements to be more precise and more supported. An example of this could be when you're fatigued during exercise, you are more likely to injure your joints when turning at speed or landing, as your muscles will have less energy to support you and reduce the impact. This is why it is good that the participant has an ideal VO2 max score, as it reduces the risk of this happening and allows the athlete to play consistently well throughout the game, as they will fatigue more slowly.